Okay, so I apologize for not being there today. I was hoping we had a little bit longer than what we did, but things happen. So, as you're kind of working, if you are stuck, please message me either on Schoology or through an email. I will be monitoring those during your class times to help you as much as I can. And we can always do a Google chat too. So, definitely reach out to me if you need help, okay? So let's kind of go over some of the things that you should have gotten out of your lesson yesterday when we're talking about a function from a relation and whether or not it's a one-to-one function or not. So there were a couple things that we needed to pay attention to with that. So the really big thing to be a function is there cannot be any duplicate x's. Okay, no duplicate x's. So that means none of the x's can be the same. Okay, they cannot be the same. So if I take a look at these maps, okay, these are maps. And maps can be circles or rectangles as long as we realize that this one is the x and this one is the y. Okay, this one's the x and this one's the y. And when we write a map, we never have duplicates. Okay, so there's no duplicates. We don't write duplicate numbers, which is something that we need to know. And then we also want to pay attention to the lines, okay? So I want you to notice that here, there are two lines coming from the x, okay? There are two lines coming from the x. And this one is not a function. And the reason it's not a function is because if I was to write these ordered pairs, that's 2, -2, 2, 2, and 8, 4. Notice how there's two 2's in the x's, okay? And so that doesn't work. We cannot have duplicates in the x's. Now let's take a look at the one to the right. The one to the right has no duplicate x's, but it does have duplicate y's. So that ordered pair, we've got 2, 8, -2, 8, and 1, 2. It doesn't matter that the duplicates are here. That doesn't matter because those are the y's, okay? Those are the y's. Now remember, one thing we talked about yesterday was the domain. So when we are looking at the domain, we have to write these fancy brackets. And those are the x's, okay? Those are the x's. So we do not write duplicates and we put them in numeric order. So if I look at this set here, the domain would be 2 and 8. The domain of the next set would be -2, 1, 2, because remember, they have to be in numeric order. The range is going to be our y's, so same thing, in numeric order, no duplicates. -2, 2, and 4. And the second one would be 2 and 8. Okay. Now those brackets are kind of hard to make, so at the minimum, just do a squiggle. Okay, let's take a look at this table over here. Let's decide, is A a function, yes or no? Is B a function, yes or no? Is C a function, yes or no? So take a minute, hit pause, think about, is A a function? Is B a function? Is C a function? If they are, tell me why. And if they aren't, tell me why. Okay, so hopefully you decided that A was yes. It is a function. There are no duplicate x's. And B is also a function. Okay, those are also one-to-one functions. Now C, on the other hand, I have these duplicate -2's. So that is not a function. Okay, that is not a function. So that is how easy it is to actually decide whether or not something's a function if you're given a map or if you're given a table. Okay, now let's take a look at the graph. So these are graphs, and we also talked about what's called the vertical line test. Okay, and that means you can only touch once. So here's these pictures. I'm going to draw a vertical line through the graph. So there's my line. Okay, we draw that again, a little bit nicer. There's my line. If I take a look at that, it's only touching once. And if it's only touching once, then it's a function. Okay, here's a vertical line. It's touching 1, 2, 3. That is not a function. Okay, that is not a function. How about this one? It's only touching once. Yes, it's a function. The next one. Yes, it's a function because it's only touching once. And even though this one seems to curve a lot, it's only going to be touched once. So it is also a function. Okay, now this next one's kind of tricky because if I was to draw the vertical line, look what happens. It's touching, 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 touching. So when I have a vertical line, it is not a function. And that happens to be an x equals a number. Okay, which we'll talk a little bit more about in our next chapter. We'll be talking, and when we get to linears, we'll be talking about lines that are vertical versus horizontal and with an undefined slope. So vertical lines are not functions, okay? Vertical lines are not functions. Okay, so the next thing we talked about was function notation. So if you remember how we read this, this was f of x, okay? F of x. This one is g of y. And the things that had to happen was these two needed to match, okay? And it was really just substitution for the most part. If I have to find f of 3, what that is saying is let x equal negative 3. So this guy is going to go here. So I have f negative 3 equals 5 times negative 3 minus 3. Now notice that the math actually happens on this side. Okay, the math happens to the right. It doesn't happen on the left. That's just notation. The math happens on the right. So I'm going to go ahead and evaluate this. Negative 15 minus 3, that's going to give me negative 8. Now, the appropriate way to write these is I start with my function notation, telling you the number that I put in, and then I write my answer. Okay, I write my answer. So f of negative 3 equals negative 8. That's the correct way to write that. Okay, let's try the next one. Again, find g of negative 5. That's going to pop in here. Okay, so g, negative 5, again, that's notation. Negative 5, remember parentheses when I substitute. Putting those in. Negative 5 squared, remember a negative times a negative is a positive. So 25 plus, and I probably don't want to have a plus there because that's actually minus 30 because 6 times, remember that's a negative 5. Okay, and I know that 25 minus 30 is negative 5, so this guy's going to drop. There's my notation. So g of negative 5 equals negative 5. That is my solution. Okay, so that's type 1. And we're going to look at a second type today after we talk a little bit more about independent variables, dependent variables, and kind of how to analyze a function. We're going to review the two types of functions again, just to make sure you're good as you move into today's practice, because today's practice you're going to have both. Okay, so if I give you this graph, so we're looking at time in seconds, and that's my x value, and height in feet, and that's my y value. So this is actually a plane taking off. Okay, so we have an airplane. It's taking off. It says the point 125, 400 tells us that 125 seconds after takeoff, the height of the plane is 400 feet. Okay, so this is where the airplane is 125 seconds after takeoff. So the first thing we have to figure out is which one is the independent variable and which one is the dependent variable. Anybody have an idea? Well, I like to think about the word independent. Okay, so if I'm thinking about the word independent and I'm thinking about that word describing a person, if I think about the word independent, I might be thinking about someone who's really strong, okay, who doesn't need other people, that can do things on their own. So if I think about the independent variable as being the strong variable, okay, it's the strong variable, I have to think about which part of the graph is stronger. Is the base the strongest? Or is the vertical the strongest? Well, if I had my hand straight up and down and I was pressing on it, this would probably fall over. Okay? But If my arm is flat and I'm pressing on it, it's not going to go anywhere. So the strong part of the graph, the strongest part of the graph is always going to be the x part, okay? That's the strongest. So that means that the x value, the x variable, is the independent. Okay, so the x variable is the independent variable. That means that the y variable is the dependent. Okay, so the reason that makes sense is because the independent causes the dependent. Okay, and what I mean by that is as time happens, the plane gets higher in the air. The height doesn't happen before the time happens. The time happens, which allows the plane to go higher in the air, okay? So one will cause the other. Independent causes dependent. Okay, so then let's take a look at this graph and see if we can do some reading of it. So let's start with this first one. So it says, what is the value of f of 250? Well, this is my x value. This is saying x equals 250. So remember, this is my x value down here. So 250 is going to be here. If I follow that up, I see I'm going to fall right in here. And if I come across, I can see that I'm somewhere probably around 1400 or so. And remember, this is feet. So what is that actually telling me? It tells me that the plane is at 1400 feet after 250 seconds. Okay, so at about 250 seconds, the plane is going to be around 1400 feet. That's what it's asking. Now let's see if we can figure this one out. So this one's saying how much time has passed if the plane is 750 feet off the ground. Well, that's my y value. So I'm going to find 750. I'm going to kind of draw a line, and I'm going to kind of come down. Where do you think I am? Maybe 155, maybe 160. And remember, those are seconds. Okay, those are seconds. So 155, 160 seconds have passed if the plane is 750 feet off the ground. So we use functions a lot to analyze what's going on. Okay, so you have to be able to read them if they give you something in function notation. So if it says f of 250, that really wants telling you x is 250. And then they're going to say something like, how far is it? How much seconds has passed if it's 750 feet off the ground? That's the y value. All right, now let's go ahead and hit the type 2 of solving functions. So we did type 1. So let's do another one of those real quick. So we have g of x equals negative 3x plus x squared when x equals negative 4, or g of negative 4. So remember, these are the same. Okay, it's just different notation asking you to do the same thing. So g of negative 4 equals negative 3. Remember, parentheses are super important here when we're substituting. We just have to have them. And then let's go ahead and evaluate that. Negative 3 times negative 4, we know that's 12. Plus negative 4 squared. Well, negative 4 squared is negative 4 times negative 4, which is going to be a positive 16. 12 and 16 is going to give me 28. So g of negative 4 equals 28 is my solution. Okay, now let's look at type 2, because type 2 is different. Type 2 is actually giving me the answer, okay, or the total. It's not giving me the x, because over here it gave me the x. It says find x when x is negative 4, or g of negative 4, which tells me the x. This time it's saying g of x equals negative 3x plus 8. Find x when g of x, that's over here, is negative 13. So my substitution is different. My negative 13 is going to go all the way to the left. And I have to solve for x. Okay, so just kind of reviewing real quick how to solve equations. Remember that you always have to add and subtract or do the inverse of things. So the first thing that has to move is the 8. So I'm going to subtract 8 from both sides. And this is going to go away. Negative 13 minus 8, that's going to be a negative 21 because those I'm really adding. Now, I know that this is multiplication. So times negative 3, the opposite is going to be divide. So to get rid of the multiply, I need to divide. So x is going to equal to positive 7. So in this case, it's very different. This one's in function notation. It's g of negative 4 equals 28. This one, it's x equals 7. Okay, x equals 7. So pay very close attention to whether or not you are substituting in for the x or whether you're actually given the total or the answer and finding x. Okay, they'll normally be asking you find x when they give you g of x or f of y, whatever it might be, versus when x is negative 4. So pay attention to whether you have type 1 or type 2. Okay, that's all for today. Let me know if you need some help.